These are very specific proofs that you're going to need to know for your quiz and test. Go ahead and copy down everything that's in the blue. You can pause it. I'll explain it as soon as you get done copying it down. So we're given that L is parallel to AB. So this line L up in my picture is parallel to AB. It's already got my arrows drawn for me. And it wants us to prove that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to 180 degrees. So what we're proving here is that the sum of the angles in a triangle equal 180 degrees. Okay? And we're going to get that from the straight line up top. So it says that 4 is congruent to 1, or measure of 4 is equal to measure of angle 1. Those are alternate interior angles. 5 and 2, those are alternate interior angles. And 5 plus 3 plus 4 up top equal 180 degrees. Well, that makes sense because they're all a straight line. So 5 plus 4 plus 3, they all add to give me 180 degrees. And then all we did was substitute. Since we know that 5 is equal to 2, we just plug it in right there. There's 5 equals to 2. And then 4 is equal to 1. So plug that in right there. And then just bring the 3 down. We substituted and got 180 degrees. Next, we're trying to prove that if two sides of a triangle are congruent, the angles opposite those sides are congruent. So we're proving the base angles of an isosceles triangle here. Okay, so we're given an isosceles triangle here, AC is congruent to AB, and it's said to draw perpendicular, the perpendicular line, AD, to CB. Okay, so we drop the perpendicular. It's kind of on its side, so you didn't drop a perpendicular, but if you're going to draw a perpendicular line, you can think of it like this. Someone drew the line like that. So if you're ever going to draw a perpendicular line, Euclid's perpendicular postulate, okay? AD is congruent to AD, reflexive property. You guys would know that. Hypotenuse leg. So if this is congruent to itself right here, reflexive property, I can see hypotenuse leg, and then CP, on the other stuff in the triangle. Next, this is kind of random right here, but the point where all the medians of a triangle intersect. You've heard the word median before. Usually, when you're talking about mean, median, mode, that kind of stuff, it would be the middle number. You line up all the numbers, least to greatest. When you're talking in geometry about a median of a triangle, a median is a line that starts at an angle and goes to the opposite midpoint. So I'm going to draw the midpoint of that line. I'm going to mark those to show that it's the midpoint. Those are my two congruent halves. And the line that starts at an angle and goes to the opposite midpoint, that is a median. So that line is a median. Okay. And I could draw, on any triangle, if I wanted to draw over here, there's a midpoint. And then I would draw a line to the opposite angle. That line that I just drew is the median, is a median. And in a triangle, there are 3 medians. Okay, so like these dotted lines over here, they're all medians. That would be congruent to that. That would be congruent to that. And that would be congruent to that. When all 3 medians intersect at this one point right here, that point is called the centroid. Okay? So medians are the lines, and then when 3 medians intersect, they intersect at a centroid. Next, we've got, we're trying to prove that opposite sides are congruent in a parallelogram. So we're given that it's a parallelogram, and by definition of parallelogram, we know that these things are parallel. Like, we know that these are all parallel. I guess I'd put 2 right there. 1 is congruent to 2, alternate interior angles, same with 3 and 4. AC is congruent to AC, reflexive property. And then the triangles will be congruent. So let's draw that. 1 is congruent to 2, and then 3 is congruent to 4, alternate interior angles. AC is congruent to itself, reflexive property. Angle side angle looks good. And then, so we're looking at the triangles now. We got to prove that the opposite sides are congruent. So we use CP/CTC because we didn't necessarily mark AB or CD, but we know that corresponding parts in congruent triangles are congruent. Okay, so that's a proof of opposite sides are congruent in a parallelogram. This looks like the exact same proof. It's a little bit longer. It goes on to the next slide a little bit. But so far, what you're able to see right now, it is the same proof. We're trying to prove that opposite angles are congruent in a parallelogram on this one. So scribble this one down, and then we'll go on to the next one. Push pause. Once you've got all, so it's the same up until right here, squiggly line, sorry about that. And then for CP/CTC, we used angle B is congruent to angle D. That's great. Those are opposite in a parallelogram. Now we just, okay, we showed that those are congruent. Now we got to show that like this whole angle is congruent to this whole angle. And that's what we do on this next one, okay? We use angle addition postulate. We substitute it in, and then transitive property. We got that 1 plus 4 is equal to A, and 1 plus 4 is also equal to C. So it's like A equals 1 plus 4 equals C, and then we marked out the middle for transitive property. We're given that this is a parallelogram. We're trying to prove that the diagonals bisect each other. There is your proof. Used CP/CTC. This proof, we're given a rectangle. We're trying to prove that diagonals in a rectangle are congruent. Once again, you have to go through CP/CTC. Something to take note of is this right angle congruence theorem and definition of perpendicular lines. When something is a right angle, you write definition of perpendicular lines. When you have a right angle congruent to another right angle, that's right angle congruence theorem. This is a pretty good little proof. You're trying to prove vertical angles here. So if you want to make a note that this is vertical angles, trying to prove that they're equal. So you're given that line L crosses line M. You're going to use definition of linear pair. So 1 plus 2 equals 180. 2 plus 3 equals 180. Did some substituting. And then down here you subtracted the measure of angle 2, measure of angle 2. We've done that before in a proof though. Going to prove alternate interior angles are congruent right here. So we're trying to prove that 1 and 3 are alternate interior angles and they are congruent. Sometimes people say, well, they're alternate interior angles. We know that they're congruent. Yeah, but you can't just say, they're congruent. That's the end of the proof. You have to use other stuff to prove that alternate interior angles are congruent. So given that we got some parallel lines, A is parallel to B. 1 and 4, those are corresponding angles. You guys know that. 4 and 3 are vertical angles. You guys know that. And then you just use transitive property. So you got like 1 is congruent to 4 is congruent to 3. I didn't put the angle symbol, I'm sorry. And then you mark out 4. Last one, you're proving the perpendicular bisector theorem. Most of that stuff we've already seen. Pretty straightforward. And on the last one, got CP/CTC.